Alright, today we'll be looking at the reverse power rule for integration. If you remember, back in derivatives, we learned about the power rule. Let's say you want to find the derivative of x to the power of n. You will use this formula, nx to the power of n minus 1. Likewise, there will be a power rule for integration, and it's called the reverse power rule because integration is the opposite of derivative. And let's say you want to find the antiderivative of x to the power of n. First, you add 1 to the exponent, and then you will divide the whole expression by the new sum. So let's say you have 2 over here, and 2 plus 1, that's 3. So the integral of x squared, or actually the antiderivative of x squared, will be x cubed over 3 plus c. And I would like to point out that this formula doesn't work if n is equal to negative 1. So I'll write down a condition here. N is not equal to negative 1, because if n is negative 1, negative n plus 1 is 0, and we all know that you can't have a 0 in the denominator. So what will you do? Well, we know that x to the negative 1 power to the power of negative 1, that is actually just 1 over x from basic algebra, right? And then, if you remember in derivatives, the derivative of ln x, the natural log of x, is 1 over x. Likewise, the antiderivative of 1 over x will be ln x. And remember to add your constant of integration. Now, let's look at a few practice problems. Let me just delete everything on the board real quick to make some space. And let's look at the first example. Let's say we want to find the antiderivative of x to the 7th power. Well, this is really simple. First, we need to add 1 to the exponent. 7 plus 1, that's 8. So, the exponent will be 8, the new exponent. And remember to divide the whole expression by the exponent shown here, which is 8 again. And then plus c, the constant of integration. Now let's see what happens when you add a constant, a coefficient. I'll use 5 as an example, and we'll use the same, actually I'll change things a bit. We'll use 9 dx. If you see a constant, you can actually move it to the front. So you'll get 5 times the integrand of x to the power of 9. And I think I won't copy the whole integrand again. I'll just straight up do the integral in my head. So we'll have x, and then 9 plus 1 is 10, and then divide the whole thing by 10 plus c. And here we can actually reduce the fraction. So these two will cancel, and then you'll get 1/2 x to the power of 10 plus c. So this is the final answer. Let me just circle this. This is the final answer. And I think that's basically it. See you guys in the next video.